Okay, here is page 4, folks, of final exam review, or at least here's most of it. I have question number 11 and question number 12, two parts of number 12, and so let's talk about these. All right, so with 11 we've got this parallelogram, and it's kind of hard to see the letters in there because they're so small, but this is what they say. Yeah, we got to figure out the values of x, y, and z here. So what are we going to do? Well, this is a parallelogram. These opposite sides are parallel, and so are these opposite sides. We have this transversal kind of running down the middle of this parallelogram, and what that means is we're going to have all kinds of like alternate interior angles and stuff like that. So first off, I can say that y must equal 20 degrees because y and 20 are alternate interior angles. Okay. In the same way, x must equal 50 for the same reason, because these two sides are parallel, so 50 and x are alternate interior angles. So the last bit is if I know that x is 50 and that y is 20, well, z must be 180 minus 70, which is 110, because of the triangle sum theorem. Okay, so there's x, y, and z for question number 11. The next part of question number 11, now we've got, it looks like a trapezoid. We've got one pair of parallel sides here. Let's see, what do we know here? Well, we know that x and y are going to be the same because they're alternate interior angles, and x is a part of this right triangle down here. So 180 minus 90 minus 65 equals x. 90 minus 65 is 25. Is that right? Yes. X equals 25. Okay. Triangle sum theorem. Okay. If x equals 25, so does y, because they are alternate interior angles. And finally, to get z, there's another triangle sum theorem situation. So we know that y is 25. This angle down here is 20. Z must be equal to 180 minus 45, which is 135 degrees. Okay, so that's a wrap for number 11. Okay, number 12, there's 3 pictures down here for number 12. Let's see what the situation is. There's an x, y, and a z. Okay, and all kinds of triangles in this picture. Okay, so I think the first thing I notice, if I'm looking at x is a part of this triangle that looks, that goes like this. One of the angles is 90, one of the angles is 55. So x must equal 180 minus 90 minus 55, which I think is 35. 35 plus 55 is 60, yes. So x equals 35. Okay, x equals 35, we could do the same thing here, right? Do the same thing here, because z is part of this triangle. So z is equal to 180 minus 35 minus 55. 55, let's see, what is this? 55 plus 35 is 60, that's 90. So z equals 90. That sounds right. Z equals 90. So now we just have to get y. Well, okay, so if z is 90, that means that's a right angle. That means that that is also a right angle, so x and y are both part of this tiny right triangle down here in the corner. If that angle is 90, and x is 35, then y must be 55. So all of this is basically just using the triangle sum theorem over and over again. Okay, so that is a wrap for the first image in number 12. What about the next one? So the next one kind of looks something like this. Got two parallel lines right here. We need to figure out x, y, and z. 60 to 130. Okay, so I see what's happening here. So down here, x is the same side interior with 130. Okay, so x must equal 50 because same side interior angles are supplementary, right? Okay, so that takes care of x. Z, well, z and x are a linear pair. So z plus x equals 180. So they're also supplementary. So z must be 30, right? Or no, z must be 130 because it's a linear pair with x, or we could even say it's corresponding with this 130 degree angle down here. So actually, I'll say that. It's corresponding with this angle down here. Okay. The last piece, well, if x here is 50, that means this angle here is 50 because they're vertical angles. And now I've got two of the three angles in this triangle over here. 60 plus 50 plus y is going to equal 180. That's 70, what's left over for y, and that's triangle sum theorem, right? Okay, so that's the second part of question number 12. There is a third one, so let's take a look at that. Alright, so what does this third image look like? This is still number 11. Kind of goes like this. Two triangles, parallel, 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 and y, 75, x, and 60. Okay, so let's take a look here and see what we've got. Oh, okay, well, if this is parallel to this, along this transversal, then y and 60 are corresponding. Okay, so y is equal to 60 because it's a corresponding angle with this 60 degree angle right here. Okay, so what else? Oh, so if y is 60, then this angle in here, oh, okay, then this angle in here is, what's 180 minus 75 equals 105, minus another 60 is 45, right? So this angle in here, by the triangle sum theorem, is 45 degrees, right? And if this is 45 and this is 60, 45 plus 60 plus x has to equal 180. Which means x is going to be, what, 75 degrees? 60 plus 45 is 105. 180 minus 105 is 75. So x must equal 75, and that would be like, I guess, linear pair. Okay? So, that's a wrap for the three images on question number 11. Or no, I should say 12. That was 12, right? But you knew that. Okay? Number 13. Okay, so number 13, yeah, I remember this one. Kind of looks like this. These are all parallel. This is 125. 2x plus y. 2x minus y. 55. We got to solve this for x and y. Okay, so this is a good one because it's there's some concepts from geometry, of course, but there's also some concepts from algebra. Namely, solving a system of equations, setting up a system of equations, and then it's solving for the two values. So the geometry part of this is all of these lines are parallel, and so what that means is we've got two pairs of same side interior angles that are supplementary. So 155 plus 2x minus y equals 180, as well as 125 plus 2x plus y equals 180, right? So I've got two equations for the two unknowns, right? If I combine these equations by adding them together, by combining like terms down the columns here, 155 plus 125 is 0, 5, 6, 7, 8, 380. Did I do that right? No, 280. 280 because, yeah, that's 10, 6, 7, 8, yes, and then 2. So 280 plus 4x, because 2x plus 2x is 4x. And then here's where kind of the magic happens. Negative y plus y is 0. And over here we got 360. 180 plus 180 is 360. Okay? One of those variables has now been eliminated, so I can just solve for x. If I divide both, or not divide, but if I subtract 280 from both sides, I'm going to get 4x equals 360 minus 280, which is 80. X equals 20. If I divide both sides by 4. So x equals 20, great. I can get y by just coming back up here and plugging it in and solving for y. I'll actually plug it into this bottom equation here. 125 plus 2x, which is 40 now, okay, plus y equals 180. Let's see, 125 plus 40 is 165, plus y equals 180. Subtract 165 from both sides, and you get 15? Yeah, 15. Okay, so that is a wrap for number 13. X is equal to 20, and y is equal to 15. Okay, onward to page 5.